Hello, everybody. Hopefully you guys are still alive and well at home, quarantined. This is a video for my pre-calc honors class as to how to graph factored polynomials because, if you're anything like me, within the last week or so, you've been bored at home and you need something to do. So this is basically a request by the district and also by some of my students then. So this video is brought to you by me, Mr. Chan, or in this case, I'll be known as Yellow Fever. So here we go. Now you'll see that unfortunately, because I suck at this whole, online thing and putting videos up online and technology in general, I'm just going to be doing things very low tech. So hopefully you can excuse me for that, and if you can't, well, suck it. Can't do much about that one. So here's our first example. What I want to do is graph something like this, where you have y is equal to x minus 1 times x squared minus 36. Like I said, it's just on factoring polynomials, so nothing too difficult. So the first thing you want to do is find all the intercepts, the x-intercepts to be a little bit more specifically, and in order to do so, we're going to go ahead and set the equation equal to 0. So you can see I did that over here, and because everything is in factored form, this is very easy to solve for. So x is equal to either 1 or positive or negative 6. So that's the first step. Now, once you find all the zeros, you're going to create a chart, and this is where it gets a little difficult at first, but, well, it's more not that it's difficult, but it's tedious. So we're going to take all the factors and create rows with them, and then at the same time, we're going to create some columns over here according to our zeros. Now, the number of columns that you have is going to be one more than the number of zeros, so you can see where my zeros at 1, then you can see the ones right here, and then you have x is equal to negative 6, so it's divided by negative 6 over here, and then x is equal to positive 6, so you can see that x is divided by positive 6 over here. So in this chart, what's going to happen is we're going to tell where the factor is equal to a positive number or a negative number. So for example, in this first space right here, for the factor x minus 1, if you take any number for x that is between negative infinity to 6 and plug it into this factor, the result is going to be negative number. So for example, if I take x is equal to negative 10 and then plug it into here, negative 10 minus 1 is equal to negative 11, and that's why this is negative. And we're going to do this for every single factor throughout the entire interval of the domain for x then. So for x minus 1, you can see it's negative for the first part of the interval from negative infinity to negative 6, and then from negative 6 to 1, and then afterwards, when x is greater than 1, you're going to get positive number and also a positive number. Okay. At x minus 6, it's going to be the same thing. You're going to create a chart there for where the graph is going to be negative, or sorry, for where the factors are going to be negative, x plus 6, and write them all out. Now, the final part right here, you can only write this part down where y is equal to after you have these three rows right here. So what's going to happen is y is going to be a function that consists of all of these factors. And the way it works is that y is going to be all of these factors multiplied together. So for example, what that means is you have to factor x minus 1, x minus 6, x plus 6, and you can see that it's all negative over here within this interval. So when you take all of these factors, multiply together, then y is going to be negative because 3 negatives multiplied together will give you a negative number. For the second part, same idea. You have 2 negative because you have 2 factors that are negative within this interval of between negative 6 all the way to 1, and then multiply by the positive over here, and so y is going to be positive. Then for the next part, same thing. So you multiply all these out. 2 positive multiplied by negative, that makes them negative. And the last interval, everything is positive, so therefore y is going to be positive. So the idea is to be able to take all the factors right here, multiply it all out, and then figure out what's happening with y. Is it going to be positive or is it going to be negative? So what you get as a result is that you see why you have something that goes from positive to negative and positive to negative. And that is something that's kind of unique because it only happens if all your factors are linear and unique. Then the intervals, if your graph of y, will alternate in signs. And you'll see what I mean as soon as I graph that then. So step 3. We now go ahead and graph our equation, our polynomial. And you'll see first what I did was I isolated all the zeros, or found all the zeros first, right? At x equals to -6, so that's over here. You have x equals to 1, so that's from up here. And then also x is equal to 6, so that's over here. Here you can see the intervals that I have isolated, just like in this chart. So for x that is less than -6, y is supposed to be all negative. So you can see that this portion of the graph, everything is negative for the y value. Between -6 and 1, everything is all positive. So that means that you're going to go from a 0 to another 0, and everything is positive. So therefore the graph has to go up and then come back down. For the interval from 1 to 6, everything is supposed to be negative. So between -1 and 6, you go from one 0 to another. You're going to dip down into the negative portion and then go back up. And then finally, everything from x is greater than 6, your graph is going to be all positive. So it's going to go up this way. So a couple of things that you should note is that this is just a sketch of the graph. So a few things right here is, one, don't worry about the local maximum or the minimum for right now for the graph, meaning that you don't really need to know what the y value is over here, nor do you need to know what the y value is over here. That's later saved for when you hit calculus. So right now it's just going to be a sketch, so that's why you don't need to know the values. The next thing is that is this graph symmetric, meaning is it equally divided going up as it is going down and so forth? The answer is no. And in terms of like how do you figure that out, unfortunately that's another mystery that's left for when you hit calculus, so you don't have to worry about that. Again, this is just a sketch, so you just have to show that it goes up and then come back down and then come back down and then go back up and so forth. Okay. Next one is label your axes, because all my students, not all my students, but some of my students have a tendency of not labeling the axes, and I want to make sure that you do that, because I don't want you to lose any points when you take one of my tests, then more specifically. As I mentioned earlier, the number of intervals for the possible sign changes is one more than the number of zeros that you have. So you can see from back up here, we have 3 zeros total. So that's why we have 4 intervals right here to consider where it's positive and negative. Before -6, between -6 to 1, 1 to 6, and then afterward from 6 on out. Okay, so this would be an example of an easy problem of how do you graph a factor polynomial then. Let's now go ahead and move into something that's a little bit more harder. So here's an example of that. So graph this equation right here, y is equal to -3 minus x times x minus 2 squared times x minus 5. Okay. So again, we're still using the same procedure. What we'll do is we'll find all the zeros, and it's easy enough to do that because everything is in factored form once again. Setting y equals 0, we solve for x, and we have the following values. Now, what makes this problem a little bit more unique is the factor x plus 2 quantity squared. And you'll see what's going to happen graphically when we have something like that. So we did step 1, which is to find all the zeros. Next, we're going to create a chart, as we said. So here you can see we have 3 zeros once again. And so I'm going to divide the x values into 4 intervals, or more specifically, the domain into 4 intervals. Again, create all, the rows for all of the factors: x minus 3, x plus 2 quantity squared, x minus 5, and so forth. I can actually put the factor x plus 2 quantity squared together because they are the same factor. So if I create a column, if I create a row for it, and I wrote 2 of them, it'll be basically the same thing. So it's okay to actually just put them together. So nonetheless, create the chart so you can see where is it positive, where is it negative, and so forth. So x 3 minus x, here you have values that are positive before x is equal to 3, and then everything else is going to be negative for x that's greater than 3 for this factor. For the factor x plus 2 quantity squared, doesn't matter what you plug in, the result is that it's always going to come out to be positive. So that's why one is going to be a little bit easier. And then for x minus 5, well, you have everything that's going to be negative before x is equal to 5. So it's negative, 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 and then afterwards positive. Once you get those three rows again, we can figure out what y is by multiplying vertically all of the values or combining all of the positive and negatives to get the result. So here you have a positive, and a negative. So when you take those three factors multiplied together, you get a negative as a result for y. And then here's the same thing, and same thing. Finally, we're going to go ahead and create the graph according to what we have as a chart. First, we're going to isolate the zeros. So here's -2, here's 3, and then here's 5. Then we're going to go ahead and use this chart to figure out what the graph actually looks like. Y is supposed to be negative, so that means everything before this, the y value is negative, before this -2. And then this part is a little bit different from before. You'll notice that from -2 to 3, your value of y is supposed to be negative. So what that means is, yes, you are going to touch the 0 at x equals to -2, and then you're going to dip back down because you are not going to go from negative to positive, but from negative to negative. So that means you're going to go up to 0, back down to negative, and then you're going to go to the next 0, which is at 3. And at that point, that's where you cross over because you're going from a negative to positive. Then from the interval of +3 to 5, where everything is positive, and then afterward x is greater than 5, you get something that's negative. You go from positive to negative, so that means it's going to go back down this way then. Okay, so the tricky part of this problem is, again, the factor of x plus 2 quantity squared. And what that does to the graph is it takes your graph and makes it so that you don't actually have a sign change at x equals to -2. So that's the unique part. And if you're wondering when does that actually happen, well, that happens when your factor is raised to a power where the power is going to be an even number then, because what it does is it creates an entire row where all the values are either going to be positive or negative. Well, in this case, it's always going to be positive because when a factor is raised to an even number, your result is that you get something that's always positive. Finally, we move to the last problem then. Okay, this one's a lot more difficult, and you're probably not going to see it, but just for your sake, for your curiosity's sake, we're just going to go ahead and talk about this one. Here I want to graph y is equal to this nasty equation, and again, you can see that it's in factor form. Hopefully, we can handle this one. Again, we're going to go ahead and solve for all the zeros. So zeros are going to be at x equals to 0 because of the x squared factor. And also x is equal to 4 because of this cubic factor. And this guy right here, x squared plus 4x plus 5, that has imaginary solutions if you set it equal to 0. So what that means is it's not factorable. And when you try to solve for when it's equal to 0, you can't. So that means the factor is strictly either positive or negative. Now, in terms of how is it going to be, is it going to be all positive or all negative? The best way to figure it out is to maybe plug in a value of x to find out. Okay, so here we can go ahead and plug in maybe say x is equal to 0 into this factor strictly and see that it's equal to 5. So therefore, it's strictly positive. So again, the best way to test is to plug in a value of x. Next, we create a graph, create a chart just like before. Our zeros are at 0 and 4, so that means we have 3 intervals for where we divide x into possible sign changes. And the factors we have x squared, we have x minus 4 cubed, and then x squared plus 4x plus 5. Create the chart as we said before. Okay, plug in a value of x into each one of these within the given interval to see where is it positive and where is it negative. Then you're going to take all the signs vertically and then combine them together to see what's happening with y. So the result is that y in this case is going to be negative, negative, and then positive. So the graph right here, you start first with everything that's negative for y before x is equal to 0. Between 0 to 4, you have values that are going to be negative because there's no sign change. And this is just in reference to what we did earlier, if you remember, for the factor of x plus 2 squared. Since it's a squared factor, then that means that x equals to negative 2. There's no sign change. So similarly over here, for my factor of x squared, right, there's no sign change at x equals 0 because of the squared factor, anything raised to an even power, as we talked about earlier. Afterward, what happens is that at x equals to 4, you are going to have a 0, but more importantly, you have a sign change. So you go from negative to positive. So the graph goes from negative to positive as over here. So it turns out that this problem, I guess the part that is tricky is that factor right there of x squared plus 4x plus 5. Because it's not factorable, it actually doesn't do too much to the graph, but what ends up happening is a lot of people get scared of it or get intimidated by it and they don't know what to do. Well, you still go through the same procedure. Try to create a chart if you can, and then from that chart, find out where is the factor going to be positive or negative, and then afterward, just graph it.